guys, what we're going to do, we're going to try something new. We're going to try a video lesson here with me and Mr. Skip over here. Mr. Skip.
Hello.
Yeah. So we're going to teach you a lesson by video, and hopefully you're going to watch it, understand it, everything's going to be clear, and then we'll come into lessons and do stuff. Right, so we're going to do lasers. I hope you can read our writing from there. Things to get feedback, yeah, we just about see that. Okay, so what does it mean? What does laser stand for? It's light amplification by putting out space, stimulated emission. This was all done by Einstein, first of all, by the way. Emission of radiation. And the S is just plural. There we go, lasers. Okay? So, what's it all about? Well, the first few keywords you need to know about coherent. Now, coherent is a word that's very particular for lasers. Most light is not coherent. You've got a light bulb, it's not coherent light. Coherent light is this. You have a wave going up and down. If you have another wave, and I'm sure you've done this in another unit, you get interference between the two. And that's going to be a problem. And unfortunately, what happens on a lot of light bulbs is that not only have you got other wavelengths going on, you've also got them starting and stopping at different points. So it starts and stops, and then starts again and stops again. And it all keeps getting in phase, out of phase. That's no good. So what a coherent wave has is it's a wave with each photon going up and down, either completely in phase, which is perfect, that's great, or even if it's out a little bit, drawing that very well, let's try again, it stays out by the same amount. So coherent is constant phase difference. And that's it. Because if it's a constant phase difference, then they must be the same wavelength as well, mustn't they? If they stay in step always at the same time, then the waves themselves must always be the same wavelength. So all lasers have coherent light, constant phase difference. Even if one of them switches a little bit, the other one's going to switch the same. So they're constantly in phase and out of phase. And that means you can get constructed interference and the wave will build up. There might be a few out of phase, but on the whole, builds up, builds up, builds up. You have a big coherent beam of light. Okay, that's one of the key words. Now, obviously, if it's coherent, it must be of the same wavelength. And a general word used to say the same wavelength, means same colour, basically, is mono, I have a monocycle, single, chromatic for colour. So monochromatic equals same wavelength. Alright, so those two words, keywords, that you need to know for lasers. Right, here we enter the first lesson. Over to Mr. Skin. He's going to teach you all the hard stuff on lasers. I've done the easy stuff. Here we go.
Yeah, cheers, thank you. Right, okay. I'm going to go through the operation of a laser with you briefly. You guys have to be able to describe how a laser works and how we get, he's rubbed it off, but never mind. You have to be able to describe how you get this monochromatic and coherent light, okay? Is that right, John?
Yeah.
Right, okay, so the whole point of a laser is to get monochromatic coherent light, and the reason for that we'll look at a later date. But that's the type of light that we want, constant phase difference and of the same wavelength. The key to operation of a laser comes from the acronym laser, light amplification by stimulated emission. So those two words are key, stimulated emission. This should be quite easy for you guys to understand because you've done very similar things in the past couple of lessons. So the key word here is stimulated emission. Okay.
Is this the point in the lesson where if we did have a class here, they'd all start sniggering? Is that right?
Yes, this is when they start sniggering because we just said stimulated emission. Right, okay. It gets worse, I'm afraid. It really does get worse. Right, so how does a laser work and what does it mean by stimulated emission? First things first, is that we need a medium through which the laser works, a medium which provides us with this stimulated emission. Now, often the medium changes in different lasers. Those of you who have read about it may have heard about argon lasers or crystal lasers or semiconductor lasers or gas lasers. Now, what they mean by that is the thing that they say, gas, crystal, neon, argon, helium, that's the medium through which we are using to create our laser. So the first thing you need is a medium. Okay, you need a medium through which you're going to create stimulated emission. Now, the medium, as the word suggests, means that it's made up of atoms. Okay? Now, before I go on to what stimulated emission means, what I want to talk to you about is just recap over what I mean by emission. Now, you know all this stuff from what you've done in quantum mechanics. Emission is the emission of light from an atom. So if we have two energy levels in an atom, emission is the process of an excited electron, this should be revision for you all, dropping down to a lower energy level and emitting a photon of light. That's the process of emission.